Section radical equations. So before we jump into solving radical equations, I'm just going to take a couple minutes to review solving quadratic equations, because that's a necessity for solving radical equations. Two ways to solve two algebraic methods. One is by factoring and two is by quadratic formula. So before we were to solve this quadratic equation, what we want to do is always make your equation equal to 0. So we're going to move this over to this side by making it equal to 0. And then using like lucky method or guess and check method or whatever your teacher has called it in the past, we're looking for factors of -6. When you add them together, you're going to end up with a -5. So the factors that would multiply to -6 would be a -6 and a +1. A -6 times a -1 would give me -6. A -6 plus a +1 would give me a -5. So these would be my factors. And then to solve this, if you can recall, you'd simply make both factors equal to 0 and solve for your x values. So should be equal to 6 and a -1. Okay, what happens when you have a value in an a value in front of your x squared? Same sort of thing. I use a method called lucky method. If you have used decomposition in the past, then please go over that method with you. But I use lucky method. So basically what I do is I look at this x squared and I say, well, the factors of 3x squared had to be a 3x and a 1x. The factors of 10, and I'm literally guessing and checking, I'm going to write this as a 5 and a 2 to start. And because this is a negative, I'm kind of thinking subtraction in my head. I'm going to cross multiply. And in my head, I'm thinking, well, 5x and a 6x, if I subtract those values, I will not get 13x. So this combination would not work. So I'm going to take my eraser. I'm going to change this to maybe a 2 and a 5. Cross multiply. This gives me a 2x. This gives me a 15x. If I subtract those values, I will get a 13x. So this is the combination I want. This has to end up to be a positive 13x. So this tells me that the 5 would be a positive value and the 2 would be a negative value. So my factors would be 3x minus 2 and an x5. So when I write my factors, I got to write this together and this together. And then to solve this, right, to solve this for 0, I'd move 2 to the other side, divide by 3. So I get a solution of 2/3, and my other solution would be a -5. Okay, so that's the two factoring methods. And then what happens when you come across an equation that cannot be factored? We resort to quadratic formula. Okay, so if you can recall, quadratic formula, just write it up top here. This is on your formula sheet, is -b plus or minus square root of b squared minus 4ac, all divided by 2a. Okay, 4 would be a, -11 would be b, and -19 would be c. So I'm going to substitute these values into the quadratic formula. -11 into my formula ends up to become a positive, plus or minus root -11 squared minus 4 times a times c. And then I'm going to divide that all by 2a. Okay, so this is simplified. This, when it cannot be factored, means you're going to get an answer that doesn't work out to a fraction or whole number. So what's going to end up is you want your final answer to be in radical form. So you don't want to find your value as a decimal. We're going to leave it in radical form. So that means you need to evaluate this expression inside your radical sign, which ends up to be a 425 over 8. And then I want to break down this 425 in most simplest form. So how I break down radicals is I say, well, what perfect square can divide into 425 evenly? And my biggest perfect square would be 25. So I'm going to rewrite this as 25 times 17 all over 8. I am then going to take the square root of the factor of the perfect square that I know, which is 25. That comes outside the radical and becomes a value of 5. And so this would be my final answer. 5 root 17 all over 8. I do want to look at all my whole numbers to see if all of these can be simplified further, but in this case they can't. None of them have a common factor, so we're going to leave it as it is. All right, so the reason why we needed to do that is to move on to actually solve equations, which we actually did in Math 20. So this should just be a quick review day. I'm only going to go over 2 examples with you. If you have any other questions, you can come see me. So the key to solving a radical equation is, the first thing you want to do is you need to isolate the radical. So what I mean by that is I'd have to move 4 to this side of the equation before I can start to do anything. Okay, after we've isolated the radical, we would want to remove the radical by squaring both sides, right? So to remove radical. So if I square this, I end up with just a 2x minus 1. Okay, and then I'm going to square the 4, which ends up to be 16. And then we have just a very simple linear equation. I'm going to add 1 to both sides. Divide by 2. So we could leave it as a fraction or write it as a decimal. Okay. So after we remove the radical, we solve equation. And then the last thing you need to do with all radical equations is you have to check your solution for what we call extraneous roots. Okay, so an extraneous root, reminder, is or we'll talk about it in the next question because this one works out. So we're going to quick check. You can either do it algebraically or graphically on your calculator, it doesn't matter. But if we checked algebraically, 2 times the 17 over 2 minus 1 should equate to 4. This ends up to be just 17 minus 1, which is 16. And I know the square root of 16 is definitely equal to 4. Actually, let's work backwards. Sorry. We have to go back to our original equation, which was minus 4 equals 0. And so square root of 16, which is 4 minus 4 equals 0. So this checks out, works out. Okay, so therefore this would be my solution. Okay. Okay, what can happen with radical equations is what we call extraneous roots. Okay, is a number obtained in solving an equation that does not satisfy the initial on the variable. So it actually, even though you got a solution, it actually doesn't work in the equation. Okay, so we're going to follow the same steps. We're going to solve this, and then at the end we got to check our solutions. So first thing we want to do is this radical has already been isolated for us, so we're going to simply take this and square both sides of our equation. But when we square a binomial, we need to put that in brackets to the power of 2, and so the square and the radical just cancel each other out. We're left with the 3x squared minus 5. Over here we need to expand this through by like foiling it, and we end up with an 8x squared plus 8x plus 16. End up with is a quadratic equation that we're going to solve. So we want to make our equation equal to 0, so the left hand side of our equation by subtracting all of these values. I am now going to factor this. So when factored using my lucky method, my factors of 2x squared have to be 2x and an x. I'm thinking 7 and 3. If I multiply 7 by 2, I get 14x. 3 by x. This works out to a 3x. So this combo actually does not work. So from here, let's try a different combination, right? So if I went 3 and 7, This works out to be 6. And 7, this also doesn't work. So at this point, what we need to do is we need to use the quadratic formula. So I'm going to go back, erase. And so using the quadratic formula, I'm going to take x equals positive 8 plus or minus the square root negative 8 squared minus 4 times a times c, all divided by 2a. Calculate that value out. Just having to grab my calculator here. Okay, so and what I end up with is a negative value inside my radical. So in fact, this actually has no solution. Because I cannot take the square root of this, we would say this has no solution. So what would that mean graphically? If I were to graph both sides of this on my calculator, this in y1, this in y2, if I were to graph this, then these two graphs actually would never intersect each other, which would mean it would be no solution. Okay, and that is solving radical equations.